So, we are back in the topic, in the name, the search of shooting a cat, and today's topic will be on the black body radiation, in which we talk about the black body, how the black body changed the perspective, how we see the quantum mechanics, and now we talk on the black body radiation and how black body radiation works and what is the real black body. So, stay with me and I will explode your mind. One, two, three, start. So, the story begins with a laboratory. Okay, just listen to me carefully. This is a story like of kind in which you can easily understand how what I'm saying. So, let's start the story. What if I told you the light itself one held the greatest secrets in the universe? That in the heart of darkness something glowed. Okay, not out of magic but because of a puzzle so deep that even the greatest mind of history stumble upon its edges. This is the enigma of black body radiation, a mystery that led to the birth of modern physics. And tonight, you and I will venture into its depth. So, it's the late 1800. The world of physics stands on the edge of a cliff. Okay, acknowledgedly staring into the abyss of a new really okay new reality. For centuries light was believed to be simple wave. Okay, and that time the light is not confirmed like a wave or a particle. The debate will be continued, but the perspective to the wave is higher, much higher, because Newton is involved in the black box, like in a wave formations of the light. Okay, so this perspective by Newton's is going to be a high demanded. Oh, okay, now you understand. Okay, let's get back to the topic. For centuries light was believed to be a simple wave behaving exactly as predicted. Okay, but the question is, no one dared to ask, how does a heated object emit light? Because we see when an object gets heated it's become a hot, a red hot, a blue hot, and a white hot, sorry, a white hot and a blue hot. Okay, so how it emit a different kind of lights when the temperature get rises and the heat become increasing. Okay, so how it emits light? What about to shatter everything we know? Okay, think think of a blacksmith forge. The iron, cold and lifeless at first, turns red, then orange, then white hot, and it's heated. Okay, but why? And why does the spectrum of color changes in the precise way? A question so simple, yet so profound that it haunted the greatest mind and one man, a German physicist named Gustav Kirchhoff. You know about the Kirchhoff laws, okay? You heard about in the science books, the Kirchhoff laws, okay? So, what gave the puzzle its name? It named it this spectrum, like this whole spectrum, the changing color, is black body radiation. He named it, the Kirchhoff named it this changing spectrums of light as the black body radiation. Here's the black body radiation topic comes, okay? A black body, an object that absorbs all incoming radiation and reflect none. Like, okay, sorry, again, sorry, reflects none. Perfect darkness, but it's not true. It's an ideal condition. Any object cannot absorb 100% of radiation or a light. It's only absorb like a 99.99%, but 0.01% is reflected by the objects. Okay, so sorry again. And yet, when heated, it shine with an angry glow, man. Okay, Kirchhoff realized something strange. No matter what material the black body was made of, okay, if its glow flowed an universal rule. But what's the rule? Stefan and Boltzmann will crack the part of the code, showing that the intensity of radiation from a black body was tied to the fourth power of the temperature. Wine would refine the mystery, finding a formula that described how wavelengths shifted from with heat. Okay, but something was off, and was that we talk about this. Okay, There's a question work for high frequencies, okay, but failed in the low. When plotted, the predictions of classical physics show something terrifying: an infinite amount of energy. Okay, listen to me. An infinite amount of energy at short wavelengths, a catastrophic explosions of ultraviolet light that never happen in reality. This was the ultraviolet catastrophe. Okay, a paradox so destructive that if true, the world as we know it should be bathed in deadly radiation. Okay. Scientists tremble. Either nature was wrong, or physics itself was broken. Enter Max Planck. Here's the Max Planck. You know about the Planck constant for them. It comes in the chapter of radiation and the blackbody radiation. And now, what he said about the blackbody radiation. Now we have talk. Okay. A man who never sought to shake the foundations of physics, yet was about to do that. Okay. In the year 1900, as a cold December night, he made a despite move. If the equations were failing, then perhaps energy itself was not continuous, but came in discrete packets. He called them quanta. Okay. And world that would echo through history. Okay. Planck's formula worked. It perfectly described the blackbody radiation. But the implications were terrifying. If energy was quantized, then the very fabric of physics needed rewriting because it shakes out the base of classical physics. But Planck was hesitant. He shows his idea as a mere mathematical trick. It took another mind, a restless young scientist named Albert Einstein, to take it seriously. Einstein proposed that light itself was made of quanta, particles of light now call photons, and with that, the foundations of quantum mechanics were laid. Okay, from the flames of simple questions, why does a heated object glow, emerge a revolution? Because this question takes a very big step to the foundation of radiation and quantum mechanics, a path that lead to the quantum mechanics to technologies that shapes our world today. Lasers, transistors, even the screen you are watching this on, all because of black bodies and their silent glowing whispers. Okay, narrate like, but the mystery didn't end here. Listen to me carefully. Decades later, physicists pointed their telescope at the universe itself and found a clue, a radiation that was neither from star nor galaxies, but from the birth of cosmos itself. Here we are finding something. A radiation that was neither from star galaxies, but the birth of cosmos itself. A cosmic microwave background. Proof that the Big Bang. And guess what? It matched the prediction of perfect black body. The universe itself carried a signature of blackbody radiation from the depth of symbol fog to the heart of universe. Blackbody radiation has whispered the secret to those who dared to listen. And as we continue to unravel the mysteries of physics, who knows what other cosmic fires still await the revolution. Sometimes the greatest mysteries lies in the simplest question, and sometimes the answer change everything. So this is what about the black body radiation. Now we are going to the Einstein perspective on the light and the quanta, and we will talk about this on the next video. So stay with me, stay updated. Dignity, let's talk tech.